Alright, today we are going to look at Mega Metric Mania, which is also just a kind of fancy name for factor label problems or dimensional analysis. Now what this is a system of using metric prefixes and numbers, factors and labels, to solve a problem using multiplication, division, and canceling units. So let's start off looking at metric prefixes. You've probably seen all of these before, but I want to review them with you because you need to know them and they're not going to be given to you. This is a ladder that starts on the left side with the largest prefix, giga. Like when you buy a computer, it has a certain amount of gigabytes of memory. Right next to giga is the capital M, mega. Then you have K for kilo, H for hecta, DA for deca, and then you have in the middle of the ladder the basic unit, which is either the liter, the meter, or the gram. Now to the right of the base unit you have smaller metric prefixes, starting with deci, then centi, then milli. Now that Greek letter that's next is called micro. It looks kind of like a fancy U. Followed by nano, and finally pico. When you're working up and down the ladder, these two hint boxes are given to you. So on the top it says if you're converting to a smaller unit, you're going to move your decimal point to the right or multiply your number. If you're converting to a larger unit and you're going left on the ladder, you're going to move your decimal point to the left or you're going to divide the number. Now the way you use the ladder is every box that you slide down or count up is a factor of 10. Let's try a problem. Alright, so let's say we have 1,000 milligrams is how many grams? So start on the ladder at milligrams, and I want you to count how many squares there are to grams. Alright, so we start at the base unit. We're going to count 3 squares to grams. Since you moved to the left on the ladder, you're going to move your decimal 3 places. So at the bottom where you see the 1,000 milligrams indicated, if we 3 places, that puts us at 1.000 grams. And that's the answer. 1,000 milligrams equals 1 gram. Got it? Alright, now I want to look at the ladder again. You see those purple boxes? Well, each one of those purple boxes also counts as a factor of 10, but they're just not named. For example, if I wanted to go from milli to micro, I would go 3 boxes. That would be a factor of 1,000. Every time you move a box, you add a 0 or you multiply by 10. The whole metric system's based on tens. So let's look at another one. If I wanted to go from mega to giga on the left side of the ladder, I would have to divide or move my decimal place 3 places by 1,000. Let's try another problem. Now on this one, the ladder method, how many grams are in 1,000 nanograms? If you start on the ladder at nanograms and you count squares up to grams, and don't forget the purple ones, let's go back and look. I count 1, 2, 3, 4, 5, 6, 7, 8, 9 squares gets me to where that base unit gram is located. Now since you moved 9 blocks to the left on the ladder, you're going to move your decimal 9 places to the left. So there's 3, there's 6, and there's 9. And the decimal ends up there. You would have to fill in all those other places with zeros. So 1,000 nanograms equals 0.000001 gram. That's the ladder method. Now we're going to look at using the metric prefixes, solving factor label style. Now factor label is using a conversion factor. So what we're going to do, always in a conversion factor, is write down what you're given. We are given 198 grams. And we want to find out how many kilograms this is. So we're going to set up a conversion factor. I'm going to put the unit that I start with on the bottom, and what I'm trying to find goes on top. This is a pattern. You're going to see it happen over and over in factor label problems. Write down the given first, and the unit that you are given will always go on the bottom, what you have, and what you're looking for is going to go on top, what you want. So then you have to put some numbers in the conversion factor. You have to think, how are grams and kilograms related? Well, the answer to that question is that there are 1,000 grams in 1 kilogram. Now once you get all this filled in, it's just a matter of doing a little bit of math. The grams that you're given cancels with grams on the bottom, and then you multiply 198 times 1, divide by 1,000, and you get 0.198 kilograms. I used the latter to figure out the 1 to 1,000 ratio for kilograms and grams. Now, you can use the latter method to do other kinds of conversion problems. Remember, the base unit is meters, liters, or grams. You can use the factor label method to do other types of conversions like time, temperature, or volume. All conversions are solved with this same pattern. You write down your given first, what you want goes on top, and what you have goes on bottom. Now these take a lot of practice, and you're going to get plenty of practice, so don't feel like you should know exactly how this works right now. We'll practice a lot next time in class. There's also some word problems that are going to be solved with conversions. Just take it slowly, just like you would any other word problem. Read it multiple times if you have to, but remember that it's just a conversion, so you have to find that given number. What do you know? Figure out what the problem's asking you to solve for, and when you figure out how those two units are related, well, that's the conversion factor. Fill in the factor and then solve. That's it.